Welcome back, mathematicians. In this video, we are going to find the exact values of the trigonometric functions of 45 degrees. Keep in mind that everything we do will also be true for the radian equivalent of the measurement of 45 degrees, which is pi over 4. So what we're going to do here is look at the triangle below, where we have a 45, 45, 90 degree triangle. What we know is that for a 45, 45, 90 degree triangle, this is an isosceles triangle. Because these two angles are congruent, it means that the sides opposite these two angles will also be congruent. If we let one of these sides equal a value of 1, then the other side must also be equal to a value of 1. Using the Pythagorean theorem, we can then calculate that the hypotenuse will be a value of square root of 2. And so this is the triangle we will use to calculate the exact values of the six trigonometric functions. Let's start with sine. So sine of 45 degrees is equal to opposite over hypotenuse, which is going to be 1 over the square root of 2. Now keep in mind we have two 45 degree angles, so it doesn't really matter which one you're using because you'll still get the same result either way. We must go ahead and rationalize the denominator, so we are going to multiply by square root of 2 to both the numerator and denominator, which will result in square root of 2 over 2. Now going forward, I'm not going to show that step in rationalizing the denominator, but know that we should rationalize the denominator for all these ratios anytime we have an irrational value in our denominator. Next, let's go to cosine. So cosine of 45 degrees is equal to the adjacent side, which is 1 over the square root of 2. And as we've just seen, this is equal to the square root of 2 over 2 when we've rationalized the denominator. Next, let's go to tangent of 45 degrees, which is equal to the opposite side over the adjacent side. So that's a ratio of 1 over 1, which is just equal to 1. Next, we're going to go to the reciprocal identities. So we're going to look at cosecant of 45 degrees, which is going to be the reciprocal of sine. You can look at this in one of two ways. You can look at this as being the hypotenuse over the opposite side, which would be square root of 2 over 1, which is equal to square root of 2. Or you can do the reciprocal of the ratio 1 over the square root of 2. You can also choose to do the reciprocal of square root of 2 over 2, but then you'll have to do a little bit more work to rationalize the denominator. Next, let's go to secant of 45 degrees, which is equal to the hypotenuse, square root of 2, over the adjacent side, which is equal to square root of 2. And so again, it is also the reciprocal of the cosine function. Finally, let's go to cotangent of 45 degrees, which is equal to the adjacent side over the opposite side, which is equal to a ratio of just 1. Now I'd like to use that information in order to find the exact value of each of these two expressions. So what we're going to do first is find the cosine of 45 degrees. Well, you might recall that the cosine of 45 degrees is equal to the square root of 2 over 2. We also need the cotangent of 45 degrees, and you might recall the cotangent of 45 degrees is equal to a value of 1. We're then going to replace cosine of 45 degrees with the square root of 2 over 2. We will then replace the cotangent of 45 degrees with the value of 1, and then we're going to multiply to get a product of square root of 2 over 2. And so this is the result of simplifying that expression. Let's now go to cosecant of pi over 4 times tangent of pi over 4. Keep in mind that pi over 4 is the radian equivalent of the measurement 45 degrees. So cosecant of pi over 4 is equal to the square root of 2. Tangent of pi over 4 is equal to 1. So we will now replace these two trig functions with their equivalent value, and so what we get is square root of 2 times 1, and the product is just square root of 2. So again, this is the result of simplifying that expression. All right, guys, good luck.